So we are continuing our lesson on the sun, earth, and moon system. And so now that we have a good idea about the moon and where it came from and uh, what its structure is like, I want you to see the effects of the moon on earth. It's not just something for us to look at night, although it does provide light through reflection, as we learned. But it also, its movements and nearness to us has an effect on the earth, and it's something that we in this state, being on the coast, actually um, do see the effects of. But before we get to that, I want to talk about gravity. We've mentioned it, but I want us to kind of look at the effects of it on the universe. So I'll give you a definition. Gravity is the natural phenomenon of attraction between objects with mass. So anything that has mass, so anything that takes up space and is made of matter, has gravity. Now, you have gravity, I have gravity. I'm sitting in my car right now recording this. My car has gravity. But compared to the Earth, which we are all on, you, me, and my car, uh, our gravity is negligible because the Earth is so dense, or the core is so dense, that we're pulled down to that. So you don't even notice the attraction between ourselves due to gravity. Now, gravity is a phenomenon, and it causes a force. So that is that attraction between objects. So when you pick something up and you drop it, that is the effects of gravity. So what does that do here on Earth, and what does that do with the moon? Well, as we talked about, the moon travels around, it orbits, revolves around the Earth. So we have gravity, the Earth has gravity and pulls on the moon. The moon has its own gravity, but it's also in motion. And we'll talk about inertia, and we'll talk about this force of motion here, which is Newton's first law of motion, that an object in motion will stay in motion unless acted upon by an outside unbalanced force. So that's this right here. That's the path it would naturally take. But this pull of gravity keeps it going around the Earth. So it revolves around the Earth because of the density, because of the mass, the gravity, and its attraction to the moon. And the moon has its own gravity and pulls on the Earth. So they end up in this rotation. So that's good for the moon, but what about beyond that? We also talked about how the Earth revolves around the sun. So the same thing, the sun is massive and has this gravitational field that's very large, and it keeps the Earth in orbit around it. So the Earth would continue to move because of Newton's first law of motion. That's inertia. It would continue to move in this forward motion, but it is pulled by gravity, the gravitational field of the sun, into this orbit, the resulting path here. So that's gravity on an even larger scale, because we know that this field of gravity reaches out past the Earth to the rest of the solar system. It keeps all of these planets, because of its immense gravity, in orbit around the Earth. Or, I'm sorry, around the sun. So that's our solar system. But now I want you to think bigger than our solar system. Let's look at our galaxy. Here is a model of the Milky Way. So it is a spiral galaxy. Here we are on the Orion arm of the galaxy. So each of these arms has names. You see there's Sagittarius, Orion, Perseus, Cygnus. We are on the Orion arm of our spiral galaxy. So what is keeping this galaxy in this shape? Well, there's a super massive black hole. So not just a black hole, a super massive black hole at the center of the Milky Way. And it is so dense that its gravity is pulling all of these stars, billions and billions of stars. Look at the scale on this. So this is like a map. Look at the scale on this. This is 10,000 light years. So this is so massive that its gravitational pull extends to our entire galaxy, pulling all of these billions and billions of stars and keeping them in orbit, keeping them in this spiral shape. Well, technically, it would be moving this way. Uh, so the way we're looking at it in a clockwise motion, but it's that dense. The gravity is that strong that it reaches out and grabs all of these stars, even on these outer arms here. It's grabbing all of this and keeping it in motion around it, keeping it in this shape. So gravity is an extremely powerful phenomenon. It has an extremely attractive force. So let's go back to the moon. Let's think about the moon's gravity and its effect on our planet. So let's talk about tides. Tides are the periodic rise and fall of the ocean surfaces caused by the gravitational force. That should say force. Let's fix that while we're here. Force. We'll save that. Force between the Earth and the moon and sun. So I mentioned that it has to do with us here in North Carolina because we are on the coast. So we can see the effect of the moon's gravity right here in our state. When we go to the beach, when we go to the ocean, we can see this gravitational force at work. So here's what happens. You have the moon pulling on the bulge of water. So our planet, we know, is covered by more than 70% of water. So the moon, in its gravity, pulls on that bulge of water, pulls it towards it. But there's another force at work here. You have the gravitational, other than the gravitational force of the moon, you also have what's known as centrifugal force. So I want to show you an example. Here, watch this kid. See how the kid is spinning around, and the motion of spinning is causing her to fly outward. That is centrifugal force. That is the same as what is happening here. How that as we go around, we tend to pull away. Same that's happening here. As the moon goes around, it tends to pull away. That's inertia. That's the path that it would normally take. And so we're seeing those effects here. This child, the path that it would normally take. Well, then you see it take that path. See this kid take the path as she lets go and flies off. That is centrifugal force. So that is actually at work on the planet as the Earth spins, as we revolve around the sun and as we rotate. And so the result is two bulges of water that are balancing each other out. So you see here is the gravitational force of the moon and this bulge of water, and then here is the balance point and the center of mass of the Earth-Moon system here, and the centrifugal force is pulling this water away. So this is the result. You have two bulges of water. So what happens is as the Earth continues to spin under this bulge, see, you have the bulge away from the moon, you have the bulge towards the moon. Well, the Earth is still rotating. We still have day and night. So as the Earth rotates, you have high tide, here where the bulge is towards the moon. And then as we turn away from it, you have low tide. Then as it turns back around away from the moon, you have high tide again. And then as it turns around this way, you have low tide again. That's why you have two high tides and two low tides within a 24-hour period. Because even though the water is bulging because of centrifugal force and gravitational force. The Earth still rotates within that bulge, and so that's why we see both high tide and low tide. So now let's talk about extremes, because while the moon has a greater impact on the tides because it's closer, the sun also has an impact on the tides. So here's what happens when the Earth, the moon, and the sun are all lined up. Now, this could be either here, like during a new moon, or it could be on the opposite side during a full moon. But during those two phases, you have the combined gravitational pull of the sun and the moon, and it's called a spring tide. So it means we have higher high tides and lower low tides. So see that combined effect here exaggerates these two tides. So that's one type. But then the other type, let's think about how our moon goes through phases. So remember, new moon and then full moon. But what about here and here? What happens to the tides when you have the gravitational force of the moon and the gravitational force of the sun kind of working against each other? Well, this is called a neap tide. And what happens is it kind of cancels each other out. Now, of course, the moon, like I said, has a greater effect on the tides because it's closer than the sun. But when we are at a first quarter or third quarter, then we're going to see those effects kind of cancel each other out. So you're going to have a little bit lower high tides and a little bit higher low tides. So again, twice a month, twice during the moon's phases, during that first quarter and third quarter, you're going to see the tidal bulge kind of start to balance out. So those are the two extremes, and this is the effect that both the moon and the sun have on our tides.